Today we are going to see about chemical energetics. Actually, these are the most important topics in this chapter in IGCSE. So over here we'll discuss about endothermic and exothermic reactions. Endothermic reactions which takes in energy, and exothermic which liberates energy, we know very well. Over here I have given one example, exothermic methane on combustion. If it's a complete combustion, it liberates carbon dioxide and water vapor. And if it's an incomplete combustion, which means insufficient oxygen, if it gets, you get carbon monoxide and water. So over here, whatever it is, this reaction is combustion. Combustion is an exothermic reaction. Which liberates the heat energy. If you see this graph, you will understand that over here, the y-axis denotes energy in kilojoules and the x-axis denotes progress of the reaction. So I've written the reactant over here, product over here. Why it is down? Why the arrow downwards over here? Which means energy liberated. The delta H will be change in enthalpy. The change in enthalpy will be negative delta H. Reason it loses energy. Okay. And over here you can see another arrow in red, which is EA. EA in a sense activation energy. What is activation energy? Energy needs to start the reaction. So from the reactant you need this much energy to start the reaction, and which leads to the product. So EA is this, and energy needs to give the product. The energy lasts to get the product, which is minus delta H over here. Okay, but what is the difference between endothermic and exothermic? Endothermic reaction, the reactants are written here and the product over here, and you can see the arrow EA from reactant to this. So what is this for? The energy needs to start the reaction. This much energy it needs to start the reaction, and then it leads to the product. So EA will be this and delta H will be this. But over here the delta H will be positive delta H, right? And we know, okay, by seeing this we can guess it whether the reaction is endothermic or exothermic fine. But how much energy it takes in, how much energy liberated, so that also will tell you difference and energy difference happen when the reaction happens, right? So that will tell you whether the reaction is endothermic or exothermic. So over here they've given the energy needs to break these bonds, C bond H, O double bond O. This much energy you need to break this bond. Okay, so over here, let's take methane on combustion. So methane on the similar example I've taken here. You have to write the displayed formula. So write in displayed formula methane C bond H. So over here you can see how many C bond H's are there. C bond H, C bond H, C bond H, C bond H. That means 4 C bond H's are there, right? So there are 4 C bond H's. So what does that mean? Over here, 430 C bond H, what is energy we need? 435. So 435 into 4, which is 1740, right? Then come to oxygen. O double bond O, which means over here, oxygen double bond oxygen, which is 497, right? So into 2, there are 2 oxygen, right? 2 moles of O2 over here we have. So which means 497 into 2, 994. By adding these two, you get 2734 kilojoules to break the reactants, right? Which means energy required to break the bond, right? Okay. Then what about the product side here? Carbon dioxide, which means C double bond O, C double bond O. That means 2 C double bond O's are there in carbon dioxide. So C double bond O is 803. So there are 2 C double bond O's. So 803 into 2, which is 1606. And water, H bond O, which is 464. So how many OHs are there? 4 OHs, 2 OHs in each water molecule. So 2 water molecules are there, which means 4. So 464 into 4 is 1000 856. By adding these two, you get 3462, which is the energy liberated when the bond formation happened. So that means, how will you find the energy difference here? Energy required to break the bond minus energy liberated when the bonds are made, which means 2734 minus 3462. And what you get here, the difference, minus 728 kilojoules. This minus negative 728 denotes it is exothermic. If it is endothermic, it will be positive, which means energy required to break the bond will be more than the energy liberated when the bonds are made, right? Okay. They might ask you with any alkanes or any alcohols too in the exam. So over here I've given one more example. This is ethane. So you have to write the balanced equation. For ethane, one more thing you have to write a C bond C. So C bond C 347, that you have to include. Keep that in mind. Otherwise, C bond H is 6, C bond H is other, like that the same way you have to calculate here. So sometimes they might give alcohol. When it is alcohol, you have to keep this in mind. Alcohol has OH, which means you have to calculate over here. C bond H will be 5, right? 5 C bond H's are there. But what else you have to calculate here? You have to calculate C bond C, and that means C bond C 347 into 1, and C bond O, single bond O, which is 358 into 1, O bond H, which is 464. I mean, these three are including when it is ethanol. Okay, other than that, everything will be same. Okay, fine. So let's move on to fuel cell, which is also a very important topic in this chapter. Over here, this is how the hydrogen will enter through the cell, fuel cell, and oxygen enters over here this side. And the electrolyte will be sodium hydroxide. So what happens here? The half equations will tell you what is the reduction reaction says. So oxygen when it enters, okay, when it enters, the water which reacts with water molecules, which gains electron. That is why we say reduction reaction, which leads to 4OH minus. Yeah, you might have seen the same reaction in electrolysis, where you get oxygen as a product the other way around, right? So over here 4OH minus you'll get. That OH minus will react with hydrogen which is entered into the cell through this way. So it leads to water. So what is the advantage over here? By using fuel cell, you'll get a only product which is water, which is not a pollutant, right? Thanks for watching this video. Hope this is useful. Thank you. Bye-bye.